Welcome to my channel. Today we look at how to find a unit vector that is perpendicular to two given vectors. We did the same using the dot product in our earlier videos, but today we want to use the knowledge of the cross product. But what we know from the knowledge of the cross product, we know that if we are given two vectors R and B, we are given two vectors R and B, what we know is that R cross B will be the vector that is perpendicular to both vector R and vector B. So R cross B will be a vector which is orthogonal or perpendicular to both R and B. So the question is a unit vector that is perpendicular. So for us to do this, the first thing we will do is to get the cross product of the two vectors. And then the vector that we will have obtained, get a unit vector in its direction. And you know, to get a unit vector of, for example, vector A, vector U, a unit vector in the direction of U will be given by vector U divided by the magnitude of U. So in other words, if we were to get a unit vector that is perpendicular to vector A and vector B, what we're supposed to do first is to get the cross product of these two vectors, and then the vector that we get divided by the modulus of A cross B, divided by that modulus. That gives us a unit vector that is perpendicular to both A and B. So let's just look at an example. And the example is find a unit vector that is perpendicular to both vector alpha and vector beta. So clearly, as we've stated above, we know that alpha cross beta will be perpendicular to the two vectors. So that is what we get. We need to get alpha cross beta. So again, we'll use our easier method of finding the cross product. So we write alpha, we write ijk, then the coefficients of alpha, which are 2, 4, 4, the coefficients of beta, which are -4, 4, 7, and then add these two columns here. Add these two columns here. And multiply along the blue diagonals as we add the result. This is 28i, and this is -16j, and this other one is +8k, and these are, we multiply along these other diagonals and subtract the result. The diagonal in red and subtract the result. This will be -14j, and this will be -16i, and this other one will be, this is -16k, but now when you subtract, you get +16k. So when we correct the like terms, this is 28i, and this is 16i minus. So 28i minus 16i gives us the 12. The 12i, and the 16j negative minus 14j gives us negative, this is 14 and this is, so that would be -30j. And then this other one k, you have 8k and 16k, they're both positive, that gives us 24k. So this is the cross product of alpha and beta. Now, with this cross product, what we're now supposed to find is the magnitude of this cross product, which is obtained by the square root of these squares, the sum of these squares. So the square of 12 is 144, the square of -30 is 900, and the square of 24 is 576. So the square root of this is 18 root 5. 18 root 5. So what are we supposed to do? What we're supposed to do is to get a unit vector perpendicular to these two vectors, alpha and beta. So the unit vector will be this divided by this. So that's what I did. So I took this, then divided by this, and that's what we have. And that's the solution that I have for the unit vector that is perpendicular to the two vectors given to us. So the other unit vector that is perpendicular to these other vectors will be the one in the opposite direction to this. So let me just say that the unit vectors here are plus or minus of this. So positive of this and negative of this is a unit vector that is perpendicular to the two given vectors.